See, just look what some chocolate can do, huh? So many people. It's great to see you. Welcome to the Science and Cooking Public Lecture Series. Who is here for the first time? Amazing, just for chocolate. See, I was speaking to you. And who has been before? Yeah, see, amazing mix of veterans and newcomers. That's great. So the way we usually do this, so my name is Pia Sorensen. I'm in charge of this lecture series, but I also teach a class that it sort of runs in parallel with this lecture series. And the way we kind of structure it is that every week we have a chef who talks about what they do, and then we use what they do to think about the science. And in the class, we have one kind of science topic for every week. And the sort of topic for this week is crystallization, which turns out to be perfect. So what I usually do is I talk for like 5-10 minutes just to kind of put you in a science mood. And if you're into science, you'll be so excited. And if not, it'll be over soon and we'll be moving on to chocolate. Okay, so I'm going to soon introduce Betty. But first, I'm going to just remind you of a few weeks ago, Jason Du was here from just down the road, Wuzhong Road. And he talked about the phase transition from when water goes from a liquid to a gas. And he talked about it in the context of steaming dumplings. Who was here for that? Okay, so you remember, right? So I thought today, basically, we're going to talk about the other main phase transition, which is when liquid goes to solid. This is unfortunately going to happen all too soon here in the Boston area. But today, we're going to talk about it in the context of chocolate. So when we talk about this, usually what we like to do in this class is think about it on a microscopic level, on a molecular level. And if we were to kind of draw out what happens, kind of do an animation of what happens when liquid goes to solid, it would be something like this. So here are the little water molecules, and you can see how in the liquid one, they're all moving freely over each other. They're flowing, which is how we know that it's a liquid, right? Water flows. If we take a glass and pour it, it flows. And then in the solid state, all of the water molecules have kind of arranged themselves into this structure, into this lattice, and they're just sitting there, almost as if all of us were to just line up and kind of hold hands in a certain structure at a certain distance, right? So it turns out what we didn't talk about in Jason's lecture was that in order to have this happen, we first have to have just a few water molecules arrange themselves in a little nucleus, a little nucleus that is a perfect crystal. So basically, in order to make these water molecules stop, we need to kind of have a first few ones arrange themselves so that other people can kind of latch on at the borders, and then the solid can grow. So if we do an animation of this, it would look kind of like this. That you have all these water molecules moving around, and then at some point, they are in perfect kind of place to arrange themselves into a little crystal, and then from there, all of these other ones can attach and grow. So this can be very, very slow. The kind of main problem of it is that it's slow. It just takes time for them to move around until eventually they hit that spot when they're in perfect kind of distance from each other so that they can form that first crystal. So and this is what I just said. Basically, the probability that they're there is very low. And because of this is super, super slow. There are various ways that you can speed this up. So here's what I just showed you. But if we found something where these first few atoms could attach more easily, and then things could grow from there, then we can kind of speed up this process. So this is kind of what I'm saying here. So if we have something that is already arranged into that perfect lattice, into that perfect structure, then it's easier for those molecules to kind of latch onto it. And then once they've done that, the other ones can latch on as well. Okay, so this may seem very abstract now, but Betty is just going to make it come alive beautifully. So this same thing basically happens in chocolate when we temper chocolate. The difference is that in chocolate, we no longer have these tiny little water molecules. Instead, we have fats. And fats are made of triglycerides. So here, this is basically a triglyceride here, and it's made of 3 fatty acids. So each of this is a fatty acid. And it turns out that in chocolate, they're called oleic acid, palmitic acid, and stearic acid. And sometimes you have 2 palmitic here and there. Sometimes you have 2 stearic here and there. But you almost always have 1 oleic. So they kind of look like that. And what happens for them to turn into solid is they would arrange themselves into kind of a solid structure, a solid lattice. And you can sort of imagine just looking at this, that maybe there are different ways it could do that, right? You could imagine it kind of looking like that, where the short one, the sort of one lone one is attaching like this to these two, right? You could imagine that. Or you could imagine that they kind of arrange like this, where these two interact with each other. So the idea would be that between each of these sort of long fatty acid chains, you can have bonds forming so that they can kind of attach to each other. And that's what kind of holds them in place. So what's amazing about the fats in chocolate is that they can arrange in these 2 ways, but in fact, they can arrange in 6 different ways. So 6 different configurations, and each one of them has its own specific melting behavior. So if you're really, who's here is like really, really into chocolate, like tempering chocolate? Okay, who recognizes this kind of phase diagram? Maybe a few. So basically what this says is that for each of these configurations, each of them kind of has a different temperature at which they melt. So the very first unstable one melts at like 18 degrees Celsius. And then there are 3 others that are also pretty unstable, and they melt at 22, 26, and 29. And then the key one, the one we want, the one Betty wants, the one all of us want, is number 5. That's the miracle phase for chocolate. That one is super stable. And then the last one is also stable, but it's not as perfect. And with not as perfect, I basically mean it's not as shiny, it doesn't have that snap, it doesn't melt as perfectly in your mouth. Basically, it's like bad chocolate. It's like the bad chocolate that you like left in your cupboard on a warm day, it melted, it got bad, you take it out, you're like, ugh, what happened to my chocolate? That's stage 6. You want number 5. Okay, any questions on that? Okay, so I'm going to introduce Betty, but what I thought we should do today, so the students in the class, they just had a midterm last week, but you don't get to have a midterm because you're free people. Sorry, I'm joking. But I thought what we should do is to give you a sense for a reason to pay attention. We're going to think of some questions as we go. We've been conspiring on some questions. And if you get them right, you have a chance to win one of our aprons. This is an apron which has all of the equations of this class on it. So you can basically cook, and you can be like, I wonder how my elastic modulus is doing, which we talked about last week. Okay, so keep an eye out for that. And with that, I'm going to introduce Betty. So Betty is from right around here, from Boston. She runs Petrova Chocolates, and you're opening a store on Wednesday?
It was supposed to be
It was
Wednesday.
supposed to, this week, super
This
soon.
week,
Keep an eye out.
Yes.
Yes.
I think we're going to postpone it for next week, just because we have to wait for one last permit, but definitely, if not this week, it's going to be next week.
So it's going to be super soon. So I think with that, we're sort of especially grateful that you're here talking to us and sharing your chocolates with us.
Thank you.
So let's welcome Betty.
Hi guys. Well, first of all, thank you for Pia and Alex for inviting me here to be today to speak to all of you. And thank you to Harvard for hosting those amazing lecture series every year. Like, I've certainly been a visitor and I've attended a few of those. So now to be here and to speak to you about something is just so amazing. So thank you all for being here tonight as well. Okay, so let's just, little technical. Okay, so you can see the presentation. So first, oh, here we go. So hi everyone. First I'm going to introduce myself. My name is Betty, and I am the chocolatier and founder of Petrova Chocolates. I formed the company in 2020 during the COVID pandemic. I used to work in the restaurant industry and I was a pastry chef, but unfortunately, like many of you, I got furloughed, so I found myself at home with a lot of free time. And to be honest with you, at one point I got so sick of baking banana bread and sourdough, I was like, I need to do something else. So the answer was chocolate, because I already worked in the pastry industry. I took several classes with renowned chocolatiers in the States. So that was just the most logical thing for me to do. So I started experimenting with recipes in my own home kitchen. And it was mostly making things for friends and family. Here I'm going to share some photos with you of the bonbons that I make. And it slowly got picked up by media, like Eater wrote an article about the chocolates. So we kind of started setting up pickup spots for pickup people to shop chocolates on our Instagram. They would message me, and then they'll come at the restaurant I worked at to pick up chocolates. So eventually, I quit the restaurant job and dedicated my full time to Petrova Chocolates, just because I knew if I want to grow in something big and to create something meaningful, I need my full attention and focus on it. So here you can see we did some quail Easter eggs for Easter, some larger chocolates. We have like some Halloween stuff that are based on popular desserts like Snickers and Bounty. Some holiday-inspired bonbons, and everything I do entirely by hand. The colors that you see, it's colored cocoa butter, which we temper, and then we paint by hand with different sponges and brushes on the molds and create the different designs that you see. And today, we're gonna start to talk about chocolate. So you saw what Petrova does, and now the question is, what is chocolate though? Well, chocolate is an emotion. It's an emotion between non-fatty components that are mixed within a fat component, which is the cocoa butter. So we have sugar, milk powders. We might have an emulsifier like lecithin that are mixed into cocoa butter. Cocoa comes from the cacao tree. We usually find this into the tropics because it requires a warmer environment to grow, like somewhere between 25 and 30 degrees Celsius. And today you're going to see a lot of Celsius in the pastry industry. We all talk in Celsius, so if you prefer Fahrenheit, just take some notes and do the conversion. I'm totally lost. I'm very sorry with this. And then cacao also requires high humidity, a lot of rain, and then the soil that it grows on is also very important. So it needs to be very high in humus. And this is because the soil would be with smaller particles, which will retain more water, and the cocoa tree loves the water. So now, how do we make chocolate? Cacao goes through a few different processes. The first one is, of course, harvesting it. With Petrova Chocolates, we only work directly with farmers, with cacao growers, and we also have some chocolate that we import from France, and we work with a small chocolate bean-to-bar maker in California, so they work directly with the cacao farmers as well. And all of the cacao that we have is sustainably sourced, it's fairly traded. So all of the labor that the farmers put in, we make sure that they're very well paid for and they have good living conditions. So first they're going to harvest the chocolate. It's done entirely by hand, a very labor-intensive process. Then the cacao beans are going to be fermented. Fermentation lasts between 5 to 7 days. And this happens in those larger wooden boxes where the cacao beans are spread out. They're covered with banana leaves, and they're going to be mixed around every 48 hours. And that is to ensure even fermentation of the cacao bean. So what is the purpose of the fermentation? This is it's an alcohol type of fermentation, first off. It's similar like the fermentation that we see when we're making wine. So the cacao bean is going to go through a few different stages of fermenting. We're going to see an alcoholic fermentation where the sugars on the cocoa pulp are going to turn into alcohol. We're going to see a lactic fermentation, and then last is going to be acetic fermentation, where the alcohol is going to be turned into an acetic acid. So during this fermenting process, we're going to develop a lot of flavor, like this characteristic flavor of chocolate. Because until then, the cacao bean doesn't smell or taste like anything like chocolate. It needs to go to fermentation process, and then we're going to dry it. Drying happens out on the sun, and it lasts a few days depending on the climate, on the weather. Sometimes farmers have like little like roofs that they build over the cacao beans just in case it rains to keep them from wetting again. Then the next step would be crushing and winnowing the cacao beans. So that basically means we take the cacao beans, we crush them, and they're going to have like little shells like you see on the photo, and we just blow away the shell because we don't want this. And then we're going to refine the cacao nib. And the refinement really, it's a specific process to the cacao maker, of the chocolate maker. Some makers prefer to have their chocolate a little on the rougher side. So they're not going to refine it for too long, but more artisanal bean-to-bar makers prefer their chocolate to be more like European style, like you know it today, like super smooth, it's going to melt in your mouth, very creamy. So that refinement will take about 12 to 24 hours. And then after we make that chocolate, it's time to temper it. And tempering is honestly not necessary. You don't have to 100% temper your chocolate. You can make your chocolate, pour it, and set it, and you can eat it. It's still entirely edible, but you're not going to enjoy as much because it's not going to have all of the crystals fully put together. So we're basically, when we're tempering them, we're controlling the crystallization of the cocoa butter. Because cocoa butter has a few different crystals. Like Pia mentioned in the beginning of this presentation, there are 6 different crystals, and they melt at 6 different temperatures. So I'm going to move over here because we're going to show you some tempering. Let's see, this is So I'm going to start to melt some chocolate while I'm talking to you first, just because this is going to take a little, and we're going to talk about the different crystals that we just mentioned. Okay, so let's see. So we have 6 different crystals, right? 1, 2, 3, 4, 5, and 6. And as Pia mentioned, they melt at different pointing temperatures. So this is 17. This one was 21, 26. This is 34. No, this is 34, my bad. And then we have 28. And 36, that's it. Just making sure I get all the temperatures right for you. So when we're going through the tempering process, you're going to see on the next slide, for each chocolate, we have different temperatures that we're going to follow. So what is tempering? We said that we're controlling the crystals of the cocoa butter. So we basically want them to make them all this crystal. We want to have all crystal 5. So this is our goal. This is our friend, and we want to be besties with this one. And we don't want 1, 2, or 3. 4, it's okay, but we mostly want crystal 5. And during the tempering process, we're not really going to create crystal 6. Crystal 6 only will create with time after you temper your chocolate, and like Pia mentioned in the beginning, you forget it in your cupboard. And a year after you go, you open it, it's going to be like very dusty, it's going to be chalky looking. If you taste it, it's not going to melt in your mouth as easily. And this is because now crystal 6 has developed. So it's going to be very firm, very dry, very unpleasant. So not good. So when we're tempering, you can see, let's say because we're tempering dark chocolate today over here. So we're going to use those numbers. So we want to bring our chocolate to 50 to 55 degrees Celsius. Why are we doing that? Because we want to kill every single crystal that we have. We just want to start from ground zero. We don't want any crystals. So the initial melting temperature will ensure that we don't have any of those crystals over here. And then when we cool the chocolate, it's going to come down to 26 to 27 degrees. So number 1 crystal, gone. 2, done. Then 3 and 4, there's going to be a little left from that, but once we warm it up to 31 to 32 degrees, those crystals are also going to be gone. So we're slowly eliminating the bad crystals that we don't want in our chocolate, and this ensures we have only crystal 5, and crystal 5 is the good crystal that will be very shiny. It's going to give us that good snap of the chocolate, and it's going to melt a little over the body temperature. So it's not going to melt in your hand, because crystal 1 and 2, they're going to be a little firm, but when you touch them, they're going to melt in your hand, and we don't want this. Okay, so this is slowly melting. So now we're going to, I'm going to show you the table tempering process. As you can see on this next slide, we have a different ways to temper chocolate. First one is seeding. What is seeding? So we're going to melt our chocolate, and then we're going to add 1/3 of the weight of the melted chocolate of tempered chocolate into the bowl and just mix it to bring it down to our working temperature. Honestly, this tempering method is my least favorite. 90% of the time I don't get it right, so it's probably me, it's not the method, because I know people that use it and they say it's fine, but it's just such a messy way of doing things. Then the next one would be the bain-marie. Bain-marie is similar with the seeding and tabling method. So it's like a little combination. So what you're gonna do is melt the chocolate in your bain-marie, like we're doing right now. And then we are going to pour a little bit on the table, and no, I'm sorry, we're not gonna do that. That's the tabling method. So for the bain-marie, you're just gonna use an ice bath, and you're gonna put the bowl over the ice bath, cool it down, and then you're gonna bring it back here, warm it up. And then for the tabling method is what we're doing today. We're heating up our chocolate. We're going to pour it on the marble slab, and by agitating it with a spatula, we're gonna temper it down to 26, 27 degrees, and then we're gonna warm it up again. And once it's in our working temperature, we can use it to create the shells for our bonbons. And then you see something called magic temper. Does anyone have an idea what a magic temper is? No? Okay, so magic temper is a pretty recent method of tempering. It was recently created, probably not too long ago, like 5 to 6 years, maybe 10. So the magic temper, the machine is like a little incubator. And this incubator is set to 33.5 degrees Celsius. And that temperature is the ideal environment to hold cocoa butter and that cocoa butter will create only crystal 5 because it will be right in that spectrum where crystal 5 forms. So when we hold the cocoa butter for 12 hours or a little longer at that temperature, when we mix it, it's going to be only crystal 5. So to temper with the magic temper, we're just going to melt chocolate. You don't have to even melt it to the full melting point. You can just bring it to 33 degrees, cool it down just 0.1, 0.2 degrees, and add 1% of the magic temper. And then that will kind of like bomb your chocolate with all the crystal 5 it needs. It's going to kick every other crystal's ass, and it'll be like, get out of here. Sorry, am I allowed? Okay, we're all grown-ups here, no children, right? And our chocolate will be perfectly tempered at that point. So we don't have to warm it up all the way up to 55. We don't have to heat it up again after we add the magic temper. We just add it, mix it, and we're done. You're ready to go. You can use it. And you can also make your own magic temper at home. You don't need this fancy machine at your house. If you have a sous vide, you can easily place cocoa butter in a little bag or a bain-marie and make a water bath, 33.5. Keep it for 12 hours, and then you're going to have your own magic temper to use to temper your chocolate. So over here, we're almost 44, 45 degrees. We're almost there. We still have some chunks of chocolate over here that we can see. Again, 37. I'm not sure if you guys can see this, but our chocolate is almost melted. 48 degrees. I think we should be fine with this. So tempering sounds pretty easy, right? Have any of you tempered chocolate at home before? How many of you have succeeded? Okay, good. Nice. So that's awesome to see. I feel like most people feel so intimidated by chocolate, but you shouldn't be. It's just chocolate. It's not going to do anything to harm you. Like, you can always eat it at the end, even if it doesn't work. It's really interesting, though, because tempering is not only just bringing it up and down to temperatures. You have to keep an eye on your room environment, like the room temperature, the room humidity, the agitation of the chocolate, because that stimulates the crystals forming. And I've also noticed that some chocolates, even though they're the same percentage, they don't temper at the same temperature. For example, I recently had to temper a 70% dark chocolate. And I've done this before, but the difference was that this 70% dark chocolate was from a smaller bean-to-bar maker, and I've never worked with that chocolate. And I tempered it to the normal 31.6 degrees. And then I made a little sample of it, and then it bloomed. So we had to change the temperature. We had to melt it to a higher point. We had to actually bring it up to 55, not to 50. And then the working temperature had to be 31.9. So a few degrees difference, but you need to play around with it. Okay. So now our chocolate is fully melted. It's up to the temperature that we want it to be, and we're just gonna pour it on the marble slab over here. I'm gonna keep some of that chocolate into the bowl. Not too much though. And then we're going to use a spatula. Bring this here. And we're just gonna move it around. So our goal here is to cool it down enough where we have only crystal 4 and 5. So when we heat it up, crystal 4, will be gone, and we're going to be left only with the crystal 5 that we want, the nice, shiny, snappy crystal. Yeah, it's been a while I've done this. I usually temper with the easy temper, and it's such a lazy way of doing things. But this is so fun. Oh my God. Okay, so we're 32.6. Keep going. Did everyone manage to get a sample when you guys came in? So those chocolates, they're made with 68% dark chocolate. So the smaller piece is the actual chocolate that I use for the bonbon, and then you can taste the bonbon is just a ganache with it, just so you can see the transformation of that chocolate. Ooh, everyone is hungry now, oh my God. Okay, we're at 38. Okay, now you can see the chocolate is like a little bit thicker. This is because we have like all of the crystal 4 and 5 in here. So it starts to look a little more like a pudding. Okay, we're at 37. So now we're gonna move it. Okay. All right, now back over here. Managed to cover myself with chocolate again. Okay. So now very quickly, we're just gonna warm this to 31. 31.45 should be ideal. Let's see. So now I'm just gonna dry this bowl. And this should have. Now we're going to take our mold and we're gonna pour this chocolate in here. Oh, I need my other hand. Okay, a little. All right. So we're just slightly tapping to make sure all those air bubbles are gone. So we're just tapping into, like you can see, the chocolate is not falling down anymore, so that should give us a good thickness of the shell. And then we're just gonna make sure we clean all the edges. And that's it. You're too nice. Okay, so now I'm gonna clean this. We can already see like some of the chocolate over here on the slab kind of set, which is a good sign. We probably tempered it right. You never know. All right, so now we have our shells. So the next step in the bonbon making process will be to make the filling for this. So this shell is going to sit, if we're not using the magic temper, we do have to wait for about 12 hours for the chocolate to fully set before we make any fillings. And the fillings are made on the day of the use. So now we're going to talk about ganaches, because ganaches is usually what we use for the fillings. And we have two different kinds of fillings, right? Like some are fat-based, some are water-based, and ganaches fall under the water-based fillings. And this is a little more interesting to speak about because there's a little more science behind it compared to the fatty fillings, because it's cocoa butter and chocolate and nuts, so nothing interesting is happening there besides the tempering, which you already saw, so no point of talking about it anymore. So ganache, how do we make it? We use different kinds of sugars. Why do we use different kinds of sugars? There are several reasons. Some is to sweeten the product, of course, for the flavor purposes. Other is for preservation purpose. So as you can see on the photo, for this particular ganache that you're tasting today, and you're going to see how we make it, we're going to use glucose syrup, invert sugar, and sorbitol. Invert sugar would be an anti-crystallizing sugar, would help us with that creamy texture that melts in your mouth when you bite into that bonbon. Sorbitol is an alcohol type of sugar, which is not really a sugar, but it gives us a little more shelf-stable product without giving us that extra sweetness. So we have two different methods of making ganache. One is the one that you are probably most familiar with, where we have the sugars and the cream in a pot. We bring this to a boil, then we pour it over the chocolate, we blend it, and then at the end we add the butter. I don't prefer this method because you're boiling your cream. So during the boiling process, you're losing some water from your cream, which will affect with your formulation of your recipe. And we're going to talk about this in a little bit after I show you how we make the ganache. So this will make a little more sense why evaporation from the cream is not very desirable in this recipe. So my way of making a ganache is a cold infusion. So we're going to take the sugars with the cream, and we're going to heat them up between 35 to 40 degrees Celsius. And then we'll take the chocolate and the butter. We're going to also melt this to around 35 to 40 degrees Celsius. And once both of those mixtures are around the same temperature, we're going to emulsify them together. So as you can see here on this video, we've already have the melted chocolate with the warmed up cream and butter. And we're just going to use an immersion blender to create a stable emulsion, because ganache is a stable emulsion between the sugars and the fatty parts in the chocolate and into the dairy fat. So at this moment, you can see the emulsion is not very stable, right? Like it's separated. You can see the butter flying on the top. So our goal here is to create a stable emulsion, which is not going to break when you pipe the ganache, and it's going to stay uniform when the ganache sets. And while you're watching this, I'm going to have some water. Thank you. So we're just making sure, like you can still see a little bit on the edges, it's still split. So just because we're making a larger batch of ganache, we do need to make sure the friction is applied for about 1.5 to 2 minutes. So temperature and friction are the two most important things you need to keep in your mind when you're making a ganache, so you can make the proper emulsion. And this looks way better now, right? So let's see, what happens next? Next, we're going to temper it. Do you remember that magic temper that we talked about earlier? So this is how it looks. This is the cocoa butter that has been held for 12 hours in the incubator. So now this is pure crystal 5. We're just putting into our ganache. So why are we tempering the ganache? Because it has chocolate. Chocolate has cocoa butter. And whenever we have cocoa butter, we want to temper that. That gives us more stable product. It gives us a better mouthfeel and a shelf-stable product. And we're just going to make sure we emulsify that very good, so the bottom of your ganache doesn't end up uncrystallized and the top is crystallized, because believe me, that happened to me before. And I poured at the bottom. I'm like, why is the bottom split? Because I didn't go all the way down with the blender. So friction is a very important thing to keep in mind. And also air bubbles. You don't want to incorporate air into your ganache, because air is also where you have bacterial growth. So if you have a lot of air bubbles, that's where a lot of bacteria is going to start to grow, and eventually your ganache is going to spoil very quickly. And you're going to get some people sick, and we don't want to see that. And now we can fill our chocolates. So now we have a luscious, stable ganache, and we're going to pipe it into our already prepared molds, like you saw how we prepared them today. So why did I say that we don't like the boiling of the cream? Because we're losing water. And when we're making ganache, another thing that we really want to keep in mind is the activity of free water. So water activity value is something that we always have in the back of our minds when we're formulating recipes. So what is this value? This value actually measures how much free water there is in your ganache. And free water is the water that doesn't bind to any other ingredients in your ganache. It doesn't bind to sugar. It doesn't hold on to anything. It's just free on its own, and that's where bacteria will grow. So the industry standard is to have the water activity value under 0.85. So the spectrum goes from 0, which means no water at all, which would be solid chocolate or pralines and gallandillas. And it goes to 1, which is pure water. So it's just the spot of water right here. So we want to be on the spectrum under 0.85. So when we're creating the ganache, if we boil our cream Today we're going to boil it for a minute. We're going to lose a certain percentage of water. We'll make our ganache thinking it's all fine because we did the formulation of the recipe and our AW on paper is under 8.5, but then we boiled more water and then the formulation is slightly different and your ganache is not going to have that same shelf stability. You're going to see bacteria growth a lot more quicker and it's not providing you with a consistent recipe. So every time you make it, you're going to boil the cream at different times, and the result is always going to be different. So that's why we do the cold method for ganache. And you can see here the different values for water activity. So when we are over 0.85, the shelf life of your recipe is going to be maximum 3 weeks, and that's top. So when we're under 0.85 and between 0.71, we're going to have 3 to 5 month shelf life of that product. And that's considering you make it properly in a hygienic way. You work clean, you work fast, you didn't leave the ganache to sit there for a few hours because you went out to do something and then you come back. You need to work in a very methodical, quick, and clean way. So here I have a little recipe. And just to give you an example how that would change, so we can see pretty straightforward, 500 grams of cream that has 35% fat, 50 grams of glucose syrup, 650 grams of 70% dark chocolate. Then we have 100 grams of fresh butter. And then I did already the math for you because my head hurts when I do math. I cannot imagine how you would feel at 8 p.m. on a Monday night. So I already did the math. So we can see the total water content in our recipe is 26.8%. The sugar is 18, the cocoa butter is 21, the dairy fat is 19.7, and then the water activity value reading showed us it's 0.95. Like even before I saw the 0.95, I can tell you this recipe is off because it has too much cream. The fresh butter can be substituted with something else and better. We don't have nearly enough sugar in this recipe to make it stable and balanced. So how can we change this recipe to drop the value of the free water and make it more shelf stable, but we want to preserve that same texture that we have here because we tested the recipe, we like the texture, we enjoy how it feels on the mouth, on the tongue, but we don't like the shelf life because this recipe will be spoiled in less than 10 days. And in a production, that wouldn't work. You at home, you can make it and enjoy it within 2 to 3 days, and that'll be fine. But for me, if I make this recipe, I'm so screwed. So here's how we're gonna change it. So we see that we had only glucose syrup. What I would do is add a few other sugars. You remember invert sugar is anti-crystallizing sugar. The invert sugar is slightly sweeter though. But we're using 70% dark chocolate, so this chocolate is already bitter. So adding a little more sweetness, it's going to cancel each other, so this recipe is not going to become too sweet just because you added invert sugar. Then I would also add some sorbitol and glycerin. And that's because I want to preserve the texture. Sorbitol will help soften that chocolate texture, and it's not too sweet either. So the only sweetness will come from the invert sugar. Then the next thing we can change is instead of using fresh butter, which has 14% water content here in America, we're going to use clarified butter. Immediately 99.9% fat. So we're losing water content from the fat. We're adding more sugar, and adding sugar always reduces the activity water value. And then we can also reduce the cream a little bit because you can see 38.4%, it's too much cream in the recipe. So if we reduce the cream, we're going to lose a little bit of fat from the cream though, so we can increase the butter, a little more clarified butter into the recipe. And then we're going to get this new recipe, which I have the percentages, and you can do the math at home to figure out the ingredients. So the total water content would be 20% max. So we've went down 6.8%. And then we also upped the sugar content. From 18, we went to 30% of sugar. because we added the invert sugar, we added sorbitol and glycerin. And then we kept the cocoa butter content the same because we already figured we like this texture, so we don't need to change the amount of chocolate in this recipe. And then we also dropped down the dairy fat content. And now, if you do a reading for your activity, water activity, it's going to show you 0.85. And now this ganache will have a shelf life between 3 to 5 months, which is exactly what we're looking for. Because when I send you that box of chocolate at home, I need to know that if you forget about it in your kitchen cabinet, it's not going to spoil in 5 to 10 days, and you can enjoy in a month after you've received them. And that's basically the science of chocolate. Thank you.
So I think it's question time, but before that, we're going to ask you questions, right?
Oh, wait, we had one more thing to do. I totally forgot.
Oh, we have more things to do. Never mind.
Well, we need to see the finished product, right? Like, yes. We made the shells, we filled them with the filling. So to create, we temper more chocolate to create the bottoms, right? But then we have to take them out, and this is fun. And then there's more samples for you to eat. So you can see here on the camera, I'm not sure if it shows, you can see the shells are already detached from the mold. So they're not stuck, which means our chocolate is ready to go. And then, voila, we have some stuck over here. There we go. I think now we can do the questions and answers section, since we got this part done.
Okay, amazing. Do you have any questions for them? I have some questions that I was thinking about. This is the quiz. This is the midterm, guys.
Ooh.
Yeah,
I think you can go ahead.
Okay, my first question, this is the warm-up question. Which is our favorite phase of chocolate? You can pick someone.
You over here.
5, that's right. Yay. Okay. You win an apron.
Nice.
I have another question. You look like you have one.
I have one, I think.
Yeah.
So we said the chocolate is an emotion. Do you guys have an example for another emotion that we see in our daily life? Oh, that's a good one.
That's a good one.
There you go.
Apron. Why did Betty use sugar in her ganache? Which you don't usually do. If you're into making ganaches, you know that you may not always do that.
Yeah, we have. Okay, yeah, that's the right answer.
That's the right answer.
Yeah.
You win an apron.
There we go. We have one more question left.
One more question. Final chance for an apron. I have one if you don't.
Go ahead.
What is one of the fatty acids in the fat in cocoa butter? You pick.
Ooh. I mean, he picked up his hand first, so let's go with you.
He was fast. That's right, oleic acid. Yeah. Awesome.
And that was a hard question, too.
That was good. You all get A's. A's to everyone.
You all pass.
Yeah, you pass. A's. I think we could stay here for hours, actually. But how about we officially, just so we don't make you too tired, not that you seem like someone who would get tired, but how about we officially end here, and Betty and us, we will stay around for a bit, so feel free to come up and ask more questions, and maybe check out some of that stuff up there.
Yeah, there's some more bonbons. Feel free to try and eat them.
There are other reasons to come up.
Yeah.
Before we thank you for this amazing lecture, I just want to tell you that next Monday we are talking about the science of barbecue. And so we're praying for good weather because we're going to be outside. If you just exit the building this way, there's a little patio, a little cafeteria outside the Alícia building, if you know the area. So next Monday at 7, there will be more goodies. And so how about with this, we thank you so much for an amazing lecture and for walking us through this delicious stuff. Thank you.
Thank you.